All right, so we have some more homework help with Jen. All right, this says, this is chapter 5, number 83. And consider the 3 flasks in the diagram below. All right, and basically I have them drawn off to the side, which will be a little bit easier to see. So let's come over to my paper. Okay, there we go. Chapter 5, problem 83. So we have 3 glass containers, and they're all connected, and they're sealed. Okay, so we have helium, 1 liter at 200 torr, neon, 1 liter at 0.4 atmospheres, and argon, 2 liters at 24 kilopascals. And we want to know, if we remove the seals on each one of these, what is going to be the pressure for each gas and the total pressure. Okay, so this is going to be how we're going to do it. The problem here is that if we zoom in a little bit, we notice that these are in 3 different kinds of units. Okay, so first of all, I can't remember exactly what it was, but we're going to manipulate this a little bit. We're going to say that we have 200 torr, and that way we have 3 significant figures on all of them. And as I peek over, I see that that is indeed the case, and I just didn't copy it correctly. We have 3 sig figs on those. But what we're going to need to do is we're going to need to convert them so that they're the 3. They're all in the 3. So since the first one is in torrs, we're going to leave that one in torrs, and we're going to switch the other ones to also being in torrs. Okay, so the neon says that we're at 0.4 atmospheres, and I have my conversion factors written here. So 1 atmosphere is the same as 760 torr. Okay, that's a defined number, so we don't have to worry about significant figures coming off of the 760. So 0.4 times 760 gives us 304 torr. Okay, so I'm going to put that up here. 304 torr. That's my new one, my new pressure. Okay, now I need a pressure for this one as well, and it tells me, so I started out with 24.0 kilopascals. Okay, so a pascal is 101,325, but I've already converted this. It would be 101.325 kilopascals. So I use that here, 101.325 kPa per 760 torr. All right, so let me explain what I just did right there. Okay, so see, if 101.325 kPa is 1 atmosphere, and 1 atmosphere is 760 torr, then I can put an equal sign here and create another conversion factor. Okay, that's a little trick for you. Okay, so now let's take a look at this. So we see 24 times 760 divided by 101.325. Okay, and that gives me 180 torr for my final pressure. So I'll go ahead and put that here. Okay, so now I've done my conversions, okay, and that was what I needed to do first. So now I'm going to use Boyle's law to determine the pressures of my gas. So this is a little trick. So first of all, let's take a look. So each one of these is a P1 and a V1. We need a P2. But so you say, well, okay, what do I need to use for my V2? Well, my V2 for all of them is my total volume. That's going to be the new volume that these gases expand to, because remember, gases always expand to fill their containers. So I have 1 plus 1 plus 2 liters. It says to assume that this is a negligible quantity in the tubes. Okay, that means that my V2 is going to be 4 liters. All right, so for helium, okay, so again, let's do a real quick solve here. P2, if I'm solving for my second pressure, is going to be equal to P1 V1 over V2. All right, so I'm doing a lot of things ahead of time so that it's easier to do 3 of them in a row. Okay, so for my helium, my P2 for my helium, we'll say P helium, is equal to my initial pressure, 200 torr, times my initial volume, 1 liter, divided by my final volume, 4 liters. Okay, so this is going to give me, well, we know that if we take 200 and divide it by 4, that this is going to be 50 torr. for the pressure of my helium. Okay, so now the pressure of my neon for my final there. Sorry, I'm really running out of room. I'll have to follow carefully. So again, I take my initial conditions, which is 304 torr times 1 liter divided by that overall 4. All right, I can't do that in my head. So we take 304 and divide it by 4, and we get 76. I'm carrying through my 3 significant figures that I have with all of these, and last but not least I have the pressure of my argon. Okay, again, initial conditions give me 180 torr times 2 liters, all divided by 4. Okay, so again, I crunch those numbers, and I get 90 torr. Okay, so those are my initial, my final pressures once the seals, the stopcocks are released, and these gases can expand. Okay, well, finding the total pressure just means adding these up. So I have 50 plus 76 plus 90. Okay. And overall I have 216 torr for my final total pressure. Okay, now so I might want to ask myself, does this answer make sense? It's always a good idea to ask yourself. So you come over here and you say, well, my initial pressures are 200 torr, 304 torr, and 180 torr. My final pressure really needs to kind of be somewhere in the middle of all of those. It's 216 torr, which is sort of in the middle of all of those, and so I feel pretty good about that answer.